The Deccan Traps, the new explanation for the Cretaceous mass extinction?
Since 1980, the impact theory has been the commonly accepted cause for the Cretaceous-Paleogene extinction event. The impact theory suggests a meteorite impact near Chicxulub, Mexico, caused a massive explosion that sent ash and dust into the atmosphere. This dust would have blocked sunlight for a prolonged period of time that would have led to planetary cooling as well as a halt of photosynthesis. Both of these things would have led to a collapse in the food chain starting from the bottom with primary producers. As of very recently, new evidence has come forward in a study by a group of scientists from Princeton University, MIT, University of Lausanne, and Amravati University that supports another previously existing possible explanation for this mass extinction event: volcanic eruptions in an area in India called the Deccan Traps. There's historically been a lot of debate surrounding this issue. It is likely that these Deccan Traps contributed to the dinosaur extinction and thus challenges the idea that solely a meteorite killed the dinosaurs.
The Deccan Traps are a very large ancient volcanic range in western India. There was a period of time when they were very eruptive, which began 250,000 years before the Cretaceous-Paleogene extinction event, also known as the KPG extinction, and continued erupting heavily for 750,000 years, releasing climate-altering gases and 1.1 million cubic kilometers of lava during this time. This volcanic activity in the Deccan Traps range likely contributed to this Cretaceous-Paleogene extinction event, which was a mass extinction of many of the plant and animal species on Earth, including non-avian dinosaurs that occurred 66 million years ago, marking the end of the Cretaceous period and marking the Cenozoic era beginning, as we talked about in class. One of the most important new aspects of the study we read about is that researchers were able to more accurately predict when these eruptions occurred and thus tie the volcanic activity to the time period of the KPG extinction. They did this using uranium and lead. Since we know the rate at which uranium decays, scientists were able to look at uranium levels in petrified lava within the Deccan Traps in the form of zircon. They then used a technique known as UPB, zircon geochronology, to compare uranium to lead decay routes and estimate the time. Researchers searched for zircon within the volcanic ash and used this uranium dating technique to then reveal that the eruptions occurred in less than 1 million years and began shortly before the massive extinction event.
The evidence of the Deccan Traps is displayed worldwide through climatic, oceanographic, and geographic changes. In general, volcanic eruptions produce great amounts of aerosols in the form of sulfuric acid droplets, which can be strewn into the stratosphere and carried over large areas on Earth. These aerosols could develop acid rain, ozone depletion, or a greenhouse effect, which are many climatic effects that were observed during the end Cretaceous period. Also around the Deccan Traps, oxygen and carbon isotope measurements suggest that oceanic temperatures and productivity fluctuated greatly during this time. Both measurements also witnessed a depression during the time after the extinction. These oceanographic changes would have upset most ecosystems, specifically because the primary producers and large invertebrates were removed from the food chains. Although this evidence significantly exhibits the effects of volcanic eruptions, it could have also been due to a bolide impact.
As this evidence is compiled, the argument that the Deccan Traps can explain the KPG mass extinction is gaining more credibility, and may possibly even displace the meteorite theory as the prevailing theory, or possibly allow for an explanation in which both a meteorite and volcanic activity working in conjunction led to the mass extinction. However, as the study is fairly new, it will take more time and study before researchers are better able to narrow down the time scale of events and better explain their findings. This extinction event, like some of the others studied in class, such as the Permian mass extinction and the mass extinction event our Earth is currently facing, reveals clues into the rich history of our Earth. While some creatures were wiped out, such as non-avian dinosaurs, others, such as birds, continued to evolve through natural selection, ultimately becoming some of the animals we know of today. Plants like angiosperms and animals like amniotes underwent radiation events and spread throughout our planet, often growing to fulfill the niches left empty by the loss of dinosaurs and other organisms from the Cretaceous period. Through analyzing the fossil record, it is possible to see this never-ending phenomenon of evolution and mass extinction. Just like the common theme of science's never-ending discovery and progress we have learned about in class, so too are theories regarding the Cretaceous mass extinction evolving.
Created using Powtoon.